Hello everyone, we will solve this today's LeetCode problem. This is trapping rainwater. This is a very famous question. You should do it anyhow. I have this question is already asked in many companies. You also, if you have given 5 to 10 interviews, then you will definitely get this question in any of the interview. Definitely, I have given 20 to 30 interviews till now, and this question has asked me many times to me also. So this is a very compulsory question. This is trapping rainwater. Let's see what does it says. So this is given and non-negative integers representing an elevation map where the width of each bar is 1, and we need to compute how much water it can trap after raining. So if you can see, this blue color is denoting water but trapped between these bars, and so we need to find the number of the volume of this water which is trapped in this bars, right? So let's see. So here, if you see the first example, this is 0 1 0 2 1 0 1 3 2 1 2 1. So this is 0, and okay, the width of this bar is 1, the width of this bar is 1, and the height will vary, right? So if you see, so first thing, if you observe, then we can observe is that and the water cannot be trapped either at the 0th index or at the last index. Why? The water will flow down to the left side of 0th and the right side of the last bar, right? So we will not consider that, right? So first observation is that I will not consider that water will not be trapped. Water will not be trapped at first and last bar, right? So this is the first observation I have. Now if you see this example, so how will the water will trapped, right? If you see, the water will be trapped. Okay, see, if you see this image, this water, how will this water trapped? If you see this water at the left side, the water can be trapped at this point, or if you see this 0, and this is again, if you see this 1 0 1 0, so the left side bar is 0 and the right side is 0 again, and this is 2, right? What I meant to try is tell is that this is 1 bar, right? And its left side is nothing, its left side is 0. So at this point, if any water comes, it will fall down to the 0th index, so it will not trap any water at first index. If you go to this second index, though this is 0th, right? If this is 0 and its previous value is 1, so it possible that it will be trapped. So we will see its right value. Its right value is 2, which is greater than 0. So water will be only trapped. Water will be only trapped if its left and right bars are bars height. If height of its left and right bars is greater than its current bar height, right? So what I mean, so it doesn't mean that the adjacent bar should be greater than, right? If you see, suppose I mark this as 0, right? This 2 becomes 0. Now if you see, its left part is 1 and its right part is 1, right? So its adjacent part is already 0. So we can also but this its left part is 1, so it will trap the water between this one to this one, right? Between this one and to this one, right? So for this 0, we will trap the water between this to this. Understood? So we need to just see that at whether its left part and the right part has some bars which is greater than its current height bar, right? if you see this this one index, right, for this one, for this one it's for this one its left part is 2, this part 2, but its right one is this part is 2, but its right one is 0. But again its right part is also already 1. So if suppose this is not here, this 3, suppose this is only the elements here, so this 0 at this 1 there will be no water present at one point, right? Because if water comes, it will not get trapped for this only index, for this one index it will not get trapped, it will overflow, because at right position there is no any bar which is greater than this, the current height of this bar, so it will not trap, it will overflow for this if we don't consider this, right? Okay, now the second observation is that how will I know determine the height of the water, because width is same for every bar, right? So how I will determine the height of the bar which is tapped on the current index, right? So if you see, we don't need to we will go step by step and calculate the volume calculate the water trapped at current index. So if you see, we will need to consider the max between max of left and max of right. What I mean, if you see this 2th value, so for this 2th, how much water we will how much what is the maximum value at left? There is no any maximum value which is greater than this 2. So so you can see this, for this 2 there is no water trapped because it will get overflow to its left side, so there is no water trapped. But if you see for this one, the maximum height which is at left is 2 and the maximum height which is at right is 3. If you see for this one, the maximum height is at 3 and maximum height which is 2. But how much water will be trapped here? So it will be both of the minimum of left max and right max, right? Because if any of the why the minimum? Because if you see, if there is why the minimum we are taking, because either if because the minimum height where it is either in left side or right side, it will above that it will get overflow, right? So for this one, the left part height is max value is 2 and the right part max value is 3. So this is 2, this is 2, how can I show? This is 2, this is 2, right? This is 2 here, and this is part is 3, this is 3. Screenshot let's delete बाद में delete कर दूँगा. So it's 2 and this is only 3, this part is 3 here, this is 3, this is 2, right? So this is 3 and this is 2, so minimum of both is 2, because above this water will get overflow for this one. And how much type of water will be there? So minimum of left max and right max minus this current height of bar, because after this bar is length this, and after this only the water gets trapped. So what the observation I can do is, I need to find for every index, I need to find left max and right max bar height for every index, right? So if we see for this 0, its left part is nothing, right? So we the water will not be trapped at first and last part, so we will don't do this for 0 anything, right? So let's see 1. So its left part is 0, right? Let's split it somehow. Okay, let's split it. Yeah, now I will see for this one, the left part max is 0 and the right max is 3. If you see, its right max is 3, right, and its left max is 0. right? Right. So, and again, I will see for this. Let's not like this is 0 comma 3. Now for this 0, its left max is 1, right max is 3. For this 2, its left max is 1 and the right max is 3. For this again 1, its left max is 2 and the right max is 3. And this will go on, right? This will go on like this. So for this 0, the right max is 2, left max is 2, left max is 3. For this one again 2, 3. Now for 3, its left max is 2 and right max is again 2. And for this 2, 3, left max is 3 and right max is 2. This for this 2, 3 and 2. For this 2, this will be 3 and 1, and for this one we will don't take it. So if you see for this one, its left max is 0 and this is 3. So how much water will be stored here? No water will be stored here. Why? Because its left max part is not greater less than is this one. So water will overflow at this point. So at this point there is no any water left, right? At this 0, both is greater than this current height. So the one minimum of 1 comma 3 is 1 plus minus this current height will be 1. So which is stored as 1, right? The water will be stored at 1. So what we need to take? We need to take the mean of left max, right max of that current index minus the height of current bar. That will be the answer for particular index, right? Of index I. So now for this 0th part, this is stored 1. For this one, for this 2 value, its left part is small than this 2, so which is not equals. Now again for this 1, both are equal, but both minimum of 2 comma 3 is 2 and minus 1, which is equals to 1. Again for 2, 3, it's 2, so it's 2 minus 0. For 2, 3, it's again 2 minus 1. For 2, 2, its smallest value is 2, but it is greater than 3. It is not, so this will not take. This is 3 comma 2, which is 2. Again 2 minus 2 is 0, neglected. Again 3, 2 is 2 minus 1. Again 3, 1, which is we will not take because 1 is less than this 2. So this is the answer. How much is 1, 1, 2, 2 to 4, 5, 6. So see, let's see, 6 is the answer, right? So here is the. So how will you calculate the left max and the right max for every index, right? So what we can do, we will move to every index and we will iterate. We can iterate in left part and the right part to calculate the left max and the right max value and take the minimum of both, right? We will move this current index and we will move to the left part and this right part and take minimum of both and minus this current height, right? This is the same. But what will the time complexity for that? That will be O of n square, right? Because for every index I am iterating in whole array, right? For let's suppose for this 2, I need to iterate in this, I need to iterate in this, and then calculate the answer for this current index. And we are doing for every this. So that will take O of n square, which is not an optimal solution, right? So how will you calculate the reduce to this O of n? So for that, if you see, what we can do, we can take a prefix max array and the left max array, right? Instead of calculating for every index, we recompute, right? We recompute to we recompute first for the we will take a two prefix max and two suffix we will take a one prefix max and one suffix max, and already stored for every index the maximum value for prefix and the suffix. What I mean that if I take a premax value, then what I can take is, for premax value, this is 0, this is 1, this is 1, this is 2, this is 2, this is 2, this is 2, this is 3, this is 3, this is 3, this is 3 again, 3 again, right? So we have computed premax. Now we'll calculate also suffix max, right? For that I need to compute from last, so it is 1. So now it is again 2, right? This is 2. For let's see here, this is 2. Let's see for now, this is 2, right? Now for this again 2. Now again 2. This is 3. Now again 3. Now again 3, because maximum value is 3, right? Right. And again 3, again 3, again 3, right? So what I can see is we are just taking as 3 and we are just marking it, right? So here we can find the maximum value, right? And what will I do? We will just move to this 1 to n minus 2 and do this. We will take both of the minimum. If you see, this is the same as this. If you see, this is the same as this, right? So this premax value is calculated already. For this one is 1, so either you can take this 0 or not. It doesn't matter, because it will already, if that is the maximum value for the left max or the right max, it will always get neglected, because both 1 minus 1 is 0, right? So if you see, this 1 comma 3 is 1 comma 3, 1 3 is minimum value is 1, 1 minus 1 is 0 for this current index. 1 minus 1 is 0, 1 comma 3 1, 1 minus 0 is 1, right? 1 minus 0 is 1. Now again 2 comma 3, minimum value is 2, 2 minus 2, which is again 0, plus 2 comma 3, which is 2 minus 1, 2 comma 3 minus 0, 2 comma 3 minus 1, 3 comma 3, 3 comma 3, 0, 3 comma 2, which is 2 minus 2 is 0, right? 2 minus 2 is 0. 3 comma 2, which is 2 minus 1 is 0. Now 3 comma 2 is 2, so 2 minus 2 is 0, and for this we will not take, right? So if you see, this 1 0 0 2 0 1 2 3 4 5 6, right? So it becomes 6 already. So what is the time complexity for this? O of n. And what is the space complexity? O of 2n, because we need to take prefix and suffix max. So here we will calculate for this. What we were doing, we will calculate for we will take a premax and the suffix max for recompute this, because I need we will recompute this, right? So for that I will take a pre and the suffix max, right? let's write as a submax, and this is premax, and we will recompute this. So pre 0 is head 0 and sub 0 is, so for this I need to calculate from 1 to n pre-computation for the max value. So this will be pre I is equals to pre I minus 1 comma this current height value, and for suffix max n minus 1 should be height. I am just initializing with the last part, and now I will iterate in n minus 2 0, right? What will be the, how will we calculate for this? We will just see the max value, so max I comma I plus 1 will be I plus 1, and this is current height. This is how we will recompute all the maximum value for every index. And now what we will do, I will store it. I will take an answer variable and I will move to every index from 1 to n minus 1. Why? Because water will be not trapped at first and last word, because it will get overflow either in left and or in right. Water will overflow at left and right for first and last part, right? It will not get trapped. So what will I do? I will increment this, take this minimum of pre-max I plus max of both left part and the right part, or you can take a good variable also, like left max and right max. Take it as a left max and right max. It will be more easy to understand. This is left max and this is right max, right? It will feel you something good, right? This will be right max and this will be left max. So we will take minimum of left max and the right max, and we will minus, what will you minus? We will minus this current height of I. But when we will do this, we will do this only when this value, okay, let's make this, yeah, when we will do this, if this value is greater than or equals to height of I, only then we will do this. Otherwise we will neglect it, because it will become 0, right? Or I can write this like this also, like max of 0 comma this val minus height, because it cannot be negative. Water trapped cannot be negative. It either is 0 or positive, so it will be max as 0 or val minus height. So yeah, and we will, at last we will return answer. Let's run. Oh, what's wrong? Oh, okay. This will be, I don't know how this square bracket comes. Let's run this again. Yeah, we have passed. Let's submit it. Yeah. So if you see, what will the time complexity field for this? So for this approach, the time complexity will be O of n, O of 2n, of course, but overall time complexity will be O of n, and space complexity will be O of again 2n, but overall space complexity will be O of n. But how can we more further optimize it? So I think we cannot more optimize it further of time, because we need to calculate for every indexed rainwater volume So can we optimize this left space part, right? So uh, can we use premax? Can we don't use premax and suffix max for calculating? Instead, can we take it as a variable and calculate along the way? So that we can move to this O of n to O of 1. So if you see, we are just calculating the premax value and the right max value for every index, right? So, and what we for every index we just want, it's just calculated premax and then just calculated the right max value, right? So if you see, instead of this left max and the right max, instead of this left max and the right max array, can we use a variable? Let's see. So here I have given uh, 0 1 0, right? This example, or can this. So if I see, if I take this as an example, and instead of calculating the left max, computing left max and the right max, I will take a variable right max and start iterating at first and at last. Suppose I am at I and I am at this C. I am at as current J, right? If I take two pointer here, so what I will check? I will check whether which is less than, because after all I need to see the minimum height between both of the max value. So I will check which bar is height is minimum. So this bar is height is minimum 0, right? So, and this bar height is minimum. What I will do, I will store it in my left max for this I. This is 0, this is less than this right value, right? So take it as this left and this is as right. So this left is at current index 0 and right is at 1. So this is less than this, right? So I will calculate this left max, which is comes to 0 again. So for this, what will be the answer? That will be the left max comma right max minimum minus the current index. So it is already 0 and this is 0, so answer will be 0, right? Now again for this one, for now this left part is over, so I will increment this left part here. I will increment for this left part, right? Now again I will see whether which is greater. So this is greater than equals to, so either we will move forward to right, or either we can move forward to left. So for now I will move forward to with left only, right? So if you see, so for now I will also update my left max, which is equals to 1, and now I will check minimum of both of the right max and the left, which is of course 0. So for this we this doesn't have any answer, so it will again become 0. Now again this left part will move to forward and this right part is still left. Now which is less than, left or right? So this left is less than. Now again we'll update left max, which is again 1 will be there, and for right max it's 0. So if you see, this left max is 1, right? So if left max is 1 and this is 0, so what will be the answer? 1 minus 0. Why? Because we need to what we will seeing previously, that we will seeing the minimum of both left max and the right max. So we are calculating the left max value and right max value while iterating it. So if my height of left value is less than height of right value, so can we not can we not tell that this left max value will be also less than this right max value at any current instance? Why? Because this height is already less than this right one, so it is possible that we will definitely either comes to this part, this right max will be definitely will be greater than equals to left max at any other future future part, right? So what we will do, we will consider this left max as 1 and minus this is 1, right? Now again I will iterate this left to forward and right is here. Now what we will check, this right value is height value is less than this left. Now I will move in right, so I will update this right max to 1 and this becomes 1 minus 1 is which is equals to 0. Now I will iterate in this, I will reduce this, right? Now this both becomes 1, so when it equals to 1 I will move left part. You can move either right or left, but I'm iterating this left part, right? So if I move left part here, so this left part will be 1 and this okay, this will also get updated. Oops, sorry, this should be left here and this right is here. Okay, now this left part is 2, so we need to maintain this left, and now this 2 minus 2 which is equals to 0, left max minus 2. Now again this I will move to this left part and right is at 2, so right is greater than this left, so we will again move this 1. So left max is 2, now left is 1, so what will be the answer? 2 minus 1, right? We are just moving every index, and which part which if I am at left part, I will store my answer left max minus left. If I am right part, I am storing my answer right max as minus right. Why? Because we are taking minimum of both of the height. So if I take minimum of the current height, so it will definitely has left max value minimum than right max. So we don't need to consider its right max value also, so we don't need to recompute. Now I will also increase this left part. Now this 0 is again less, so this will becomes 2 minus 0. Now again this left part should move, this right is, now again 2 minus 1 is 1 because we will update that. Again it moved to 3, it will move to 2. Now this right is height is less than this left part, right? So this right part is 2 and this left part is 3, so we will see update this right max value to 2 first, and then now we will calculate with right max minus right value, which is 2 minus 2 is 0, right? Now I will shift this right to minus opposite. Now this again, this is right value is 1, which is less than this 3, again 2 minus 1, right? Now I will again shift this, again it is small, it will becomes 2 minus 2 is 0. Now this right will becomes at this part here, right? This at 3 index, so 3 is we will both update to this 3 and 3, which is equals to 3 minus 3, which is 0. Now this right will be here and this, okay, so this left will be here, which is not greater than, we will definitely got the answer. This is 1, 1 plus 1 2, 2 plus 2 is 4, 4 plus 1 is 5, 5 plus 1 is 6, so total answer is 6. So what we have done, so what we have done, so what we have done, we have just calculated, we are taking two variables L at 0, left at 0, right at and minus 1. And what I am doing, if height of L is less than equals to height of R, height of right, what I'm doing is I'm just I will update my left max value. I will update my left max value, and I will update my left max value, and what will the answer I will store? Left max minus this current height, right? And this same goes for opposite part. If it is less, then what I am doing, just opposite part. I will update first right max and then store the difference between them. Right max, right max, right max. Bas. That's how it is. Just how it is gone. And also I need to update this left part, left plus plus. Otherwise it will give TLE, right? Right, minus minus. Right. Sorry, this should be right, left. I think you got the approach, right? So instead of pre-computing arrays, I will update iteratively, right? Whenever I get an index, I will iterate left max and right max again and again. So it's just if you don't understand, you can just take out pen and paper and do this, right? Because we need to find a minimum of both left max and right max, and minus this the current height of part. This, that is the intuition. So overall conclusion is this only, that we need to find left max and right max and take minimum of both, and answer will be the difference between the current height and the mean height, right? That's the only approach which is here. Either you use left max pre-computation, either use variable. We can do it also using a stack. This is an homework for you. How will I do it using a stack? So it is on you. Let's see how much persons are do this. We can also do using a stack. This is will not, it will tell you. So let's code it for this left max and the right max value, right? So what I will change, I will just change this value, vector end. Instead of this, I will take left max, which is current is 0, right max, which is at 0. I will not compute this, so remove this, also remove this. I will need to take a left variable 0 and the right variable n-1 for pre-computing. What I will check, if this left value is less than right value. Now what will I check? I am checking, I have just I will use this pseudocode here. So what this pseudocode tells us, if my height of left part is less than height of right part, what I will do, okay, what I will do for this, what I am doing for this, I am first update left max value, and I need to store this max value, what which was in the previous case, this 0, because it cannot be negative, right? So for that I need to take max as value 0, and now will update left max. Else I will do this the same thing for the right max value, right? The pseudocode which I was written previously, I'm just using that. There are no changes in this. So if my left part is less than equals to right, I will update move to my left because I need to maintain minimum of both. And if I this, I will move to right and I store along this. In this I also need to see whether this is max 0 or not. 0, and this is right. So yeah, this should be the answer. Let's run this. Okay. Let's run. Yeah, we pass the sample case. Let's submit it. Yeah, we pass the solution. So we have successfully optimized it from O of n square to O of n, and then O of n to O of 1. So what we have done, we observed that we observe that we need to find for every index the left max value and the right max value. So first approach was that for every index we need to iterate for in its left and its right, so that will take O of n square. So for that, and to handle that, we will computed two arrays for left max and the right max for every index, and for go and move to every index and find the minimum of both left max and right max, and updated the answer. Now that will take O of n space and O of n time complexity. So for reducing that space of n to O of 1, what I have taken, I'm not recomputing the left max and the right max. Instead I will take a left max variable and right max variable and update as we move forward in left part or right part with the help of two pointer approach, right? So that's how this goes. Yeah, if you we can also solve this using a stack, but it again takes it again takes open time, and space will be also of 1. So it's same as the left max and the right max pre-computation using a stack, right? So yeah, I think it's upon you whether you see that or not. So this is homework for you. Let's thank you.